polynomial division. That's our algorithm that we know. The polynomial is ax times qx plus rx, ax being the divisor, qx being the quotient, and then when we do our division, sometimes we're left with a remainder. Couple of notes. The degree of the remainder will always be less than the degree of the divisor, because if it's not, well, then you can keep dividing. And qx and rx, the quotient and the remainder, are unique, right? Because if they were the same thing, again, you could do a division into the remainder. Oh, there's an old question. 1998. Find the quotient of the remainder when the polynomial is divided by x squared plus 1. X squared plus 1, but remember, I'm going to need to include all of the missing terms for the sake of my division. So I've got a naught x cubed and a naught x there as well. And when we are dividing, it's just the leading terms that we're dividing. So in this one, x to the power of 4 divided by x squared, which is of course x squared. And then we multiply that out. I get x to the power of 4 plus x squared. Subtract, bring down those terms that I haven't used yet, and go again. So x squared goes into minus 2x squared, minus 2 times. Multiply that one out, do a subtraction, I'm left with 3. But now that's where I stop, because the degree of the remainder is 0 in this case. The degree of the divisor is 2. I can't keep going. So my quotient is x squared minus 2 and my remainder is 3. Wow, an even older question. They want us to do this division. Alright, again, x squared into 2x to the 4 will go 2x squared times, multiply out, do a subtraction. We can keep going. So x squared into 4 or minus 4x cubed is minus 4x, multiply out, do our subtraction, and we can keep going, because x squared will go into minus 2x squared. That one can work. We get minus 2. Multiply out, subtract down. Our remainder is just negative 1. So I've done the division. Now rewrite it as our algorithm. So divisor times quotient plus the remainder, and there we have it. The other thing we saw it was useful for is this graphing idea. When we have a rational function on a rational function, we can do a polynomial division and rewrite it, and effectively we get the quotient plus the remainder on the divisor. And when it was in that form, we could tell a lot of things about our graph. We know the bottom of the fraction can't equal 0. That's going to give us the vertical asymptotes. We know the quotient will be the horizontal or oblique, depending on what that quotient is, asymptote. And the remainder can tell us whether or not our curve cuts that horizontal or oblique asymptote. And if it's possible for the top of that fraction to be 0, then yes, it would cut it at that particular point. So if I had to sketch this sort of thing, I've already done the division. Y equals x plus 8x on x squared minus 9 we want to draw. Now we know we've got vertical asymptotes. That's the bottom of the fraction. That's going to be at plus or minus 3. Draw those in. We've got an oblique asymptote at y equals x. Put that one in. In this case, it is possible for the remainder to equal 0. It will be at x equals 0. So we know our curve will go through the origin right there. And if I was to complete the curve, remembering all our ideas of bending towards asymptotes and things like that, we get this curve there. Shall I do a split away?